Hello and welcome to IGCSE review for Add Math, and this is the chapter 13.4, sorry, which is on the different forms of differentiation and different forms of functions where you can learn to differentiate with, because given that the power rule, as I said previously, which is suppose we have a function xn or axn, doesn't matter. F prime of x would be the value n a x n minus 1. So you bring the power down and then minus the power on top. So this will not work in the cases where you have the functions. Suppose you have the function f of x equals to in the form ax plus b to the power n, where, say, if I were to give an example, something like 3x plus 5 to the power 6. You can't use the power rule in that sense. So when suppose you have a function like in a product of two functions like g of x and h of x, something like, suppose you have this function 3x squared and then ln x or something like that, and then, or say sin x or whatever, and then suppose you have the function of a rational function which is like this in the form of g of x over h of x, where g of x and h of x are individual functions, and an example could be 3x cubed over 5x squared, and we'll be doing both of all these together. So suppose I'll do the derivative of this one first. So f prime of x for this one would be bringing out the power, which is 6 here, bringing it down, similar to this case, 3x plus 5, and then take down the power on top, take it down, and then times by the derivative inside, which is now then therefore equals to 3x plus 5 to the fifth. So basically the full thought process of this is that you're going to sub in the 3x plus 5 as u, and you're going to take and then so what happens is that you're left with u6, f of x equals to u6, and you want to take the derivative of du over dy over du, and which gives us 6u fifth, and then you're going to take the derivative of the u inside, so the derivative of x here, which equals to 3. So the chain rule is essentially dy over dx equals to dy over du times du over dx, which will give you which is 6u to the fifth times 3, plugging in back in 6u 3x plus 5 to the fifth, 3x plus 5 to the fifth times 3, which is 18, 3x plus 5 to the fifth, seen here. And for the g of x, h of x, I'm gonna want to have this in this form: f of x, g prime of x, h of x, plus h of x, h prime of x, right? G of x. So we're gonna want to take the derivative of one function, and then leave the other one the same, and add on the derivative of the other function and multiply it by the original function of this one. So suppose we have this function 3x squared plus and times by ln x. We don't actually know what ln x, the derivative of ln x is yet, so I'm going to introduce it to you now. The f prime of x of ln x would be 1 over x. So let's start with the f prime of x here. So 3x squared will give us 6x, and leave the original function ln x, and add on. It doesn't actually matter what values in what order we put it in, since it's commutative in the sense that it's plus, not minus, which is not commutative, which we'll see later on. Commutative meaning that we can swap both sides and it still gives the same value. Multiplication, for example, is commutative, but division is not. And then h prime of x, which would be 1 over x, I said before, and here, and then the original function 3x squared. All over, okay, then this is basically the derivative here. And if you can further simplify it if you want to, but I don't think it's necessary for our case. And then something like f of x, now for the quotient one, f of x gx, g over hx, 3x cubed, which was 3x cubed over 5x squared. Our form of the our formula for this is that f prime x equals to the prime of the top function, h of x, the original function back, minus h prime of x, g of x, the original function here, all over h squared x, which means the value squared, the bottom value squared. So if I were to bring it over here again, the initial problem, which was 3x cubed 5x squared, f of x equals 3x cubed over 5x squared, and so f prime of x should follow this one, the top function, the derivative of the top function, 9x squared, and then times by the original function minus the bottom function prime and original function again, and all over 5x squared all squared. So this is basically how you take the derivative. You can simplify if you want to, and notice that it matters which way you put the values in, because you must put the top one, the prime of the top one first, and then the original function minus that one here, because minusing something is subtraction, is not commutative, and it therefore matters which way you put it, otherwise it will not work and it will not turn out to be the same value. And this is basically it covers up most parts of the differentiation part of the course, and most of these ways can be applied to different problems requiring differentiation in IGCSE at math papers. Thank you.